So before I jump into the details on using DCM, I just want to just do a quick overview here. There are 14 slides that I just skipped past that you're welcome to go back and take a look at. And if I have time, I'll do that. But basically, I wanted to talk a little bit about TLS 1.2 and 1.3 and the handshake that takes place between server and client in those different protocols. You're going to see here that there are different ciphers. Okay, so we have a key exchange algorithm. We have authentication, digital certificate algorithm, bulk encryption algorithms, and a message authentication. Those four different ciphers are what make up what's called a cipher suite. And that's the only point I'm going to make here. We don't have to go into detail. We can later maybe, but I just wanted you to understand that, cipher suite has to do with the way that the protocols use the ciphers during the stage of the handshake. Enough said. Okay, and as part of that talk about ciphers, we can certainly take a look at what's available on IBMI. On my IBMI, I have these cipher suites available. And actually, if you notice, there's a big difference between the first three and the last six. First three are actually 1.3 protocols because you see there that there's only three different ciphers in the suite. And in the last six, there are four ciphers in the suite, and that's really the indication that it's a 1.2 protocol. Again, enough said. Okay, so we want to use this digital certificate manager as a certificate authority. That means that it has the ability to issue certificates, and those certificates will be checked back against the CA, which in this case will be the DCM. So let's talk a little bit about how that works. And also that the DCM as acting as a certificate authority can generate certificates, but it can also generate what's called a certificate signing request, which can go to a third party, and that third party can issue the certificate, which can then be imported back into the DCM certificate store. We're going to take a look at both of those. We're going to start with setting it as a certificate authority. Now, in order for it to be a certificate authority, you got to have, of course, you got to have DCM already set up, and you need to do a couple of basic things, which is basically create two different stores. They may already be set up on your IBMI, probably are, local CA and Star System Store. So that allows us then to generate, first of all, a root certificate for the CA, DCM, and then that root certificate will be used for generating other certificates that will be, again, validated against the root certificate, the CA certificate. If we're using that self-signed certificate outside of DCM, we can export the CA certificate, the root, import that into a browser, for example, so that the browser knows and can trust that connection to that self-signed certificate. Self-signed certificates are free. You can generate as many as you want. There's longer renewal periods. I think they're less than 3 years now. I think they're just under a year. But it doesn't scale well. You got to distribute that root certificate, that CA certificate has to be available to the client so it can validate when it grabs that certificate that it's actually the domain, the authority that it says it is. But it can be used to secure IBMI apps. Okay, so using it as a certificate store, you're going to create a certificate signing request, a CSR, that's sent off to, Entrust or Sectigo or whatever. And that certificate authority will send back the certificate it's generated from the CSR. That scales very well because that's part of this public key infrastructure, PKI, that we didn't go into details on, but is just a method for authenticating that certificate that's delivered by a server to the client is a valid certificate and has been authenticated through some vehicle, in this case, a certificate authority. And it also, any those third-party certificates can easily be used to secure IBMI apps. Okay. There's a couple of different types of certificates. One I call a standard, which just is securing subdomain domain combination like www.myapp.com. And there can also be in that standard domain certificate a list of different subdomains that will be secured. But there's also this thing called a wildcard certificate, which I use quite a bit because that'll secure any subdomain on the domain. So like starmyapp.com will secure www.myapp.com, api.myapp.com, but it won't if there's a subdomain of the subdomain www.market.myapp.com. So the cool part is they're very flexible. If you have a subdomain domain combination and then decide to add another subdomain, you have a certificate already available that will work with that subdomain. So there's some basic setup of DCM, which I'm quite certain your IBMI has probably already gone through. And it's just checking to make sure that the system and local CA stores have been set up. There's really, and those are trivial steps anyway. So the first thing that we need to do is to create the local CA certificate. Okay, so this is the root. And then once that's available, we can download it and then we can export it so that it can be used in either a browser or in some cases like a Java, it could go in the key store of a Java application so that it can talk to your server securely. Again, CA certificates, the root certificates are key in being able to establish secure communications over TLS. Okay, really simple. And this is going to be like lather, rinse, and repeat over and over again because creating the CA certificate authority certificate, creating the self-signed certificate, creating the CSR to create a certificate, they're going to have all these same fields of information, basically. So common name, you can give it any kind of name for the CA. And then, of course, organizational unit, you can see the red X's and the green checkbox. The X's say, hey, you got to fill this out. So typically, you're going to use your organization. You'll create some name for this CA certificate. It'll have to identify what state you're in and what country. And basically, you create it. So let's take a quick look at that because it's so straightforward. It'll create a certificate that looks like this, and then you can export it. So let's jump over to our DCM. Okay, so here's the login for DCM. Now, you got to open a certificate store. And in this particular case, since we're going to create a local certificate authority, we're going to use the local CA. Now, you can create as many CA certificates as you want. I'm not exactly sure why you would want to have multiples, but there could be a use case for that. As it turns out here, I've got one that's been around for quite a while, and it's about to expire. I've got a new one here that I've specifically created for a common PowerUp, the PowerUp conference that was in New Orleans. And so really not much to it. You click create. And again, I typically use RSA This is the validity, roughly 3 years for the CA certificate. You can give it a common name, any name at all. You put in your organization and all the other details, then you click create, and it creates a certificate. Now you can see I've done this multiple times, and than create even more CA certificates, I'm just going to leave it as this. But here's that common name. There's the organization unit, the name, state, locality, where we are. And then it generates this label, and that'll come into play later. But this label, you're going to have a label on every certificate. This one was generated by the system. It's going to be local certificate authority and then the serial number of your I. And that's basically it. Once it's here, you're good to go. All right, so now that you've got the certificate authority certificate, the CA root, basically, you can create certificates using that certificate. Let me jump back to my slide deck, make sure I'm not missing anything here. This is the export for it. Yep, so let me just talk a little bit about exports. When you export it, it's going to, I always choose downloads, and the download folder is this in the IFS. You'll find it there, and then you can just download it and use it. Download it out of the IFS and then import it into whatever application you need to. Okay, so the next step after creating this certificate authority certificate is to use that certificate authority to create more certificates. And these certificates could be used specifically for applications, whether that be a website or whether that be an IBMI application. And so you generate the certificate by choosing, first of all, that you're going to generate it from this local CA. And then basically, these are all the same things you've seen before. But let me talk a little bit about when you're generating this certificate about subject alternative names. And in order to make that really clear, let's go ahead and jump back to DCM really quick. And let's go back. We're in the local CA. We need to open up the system certificate store. We're going to create a certificate, and we're going to create a certificate in the system. That's a little confusing. In the system certificate store, but using the CA from the local CA store. So take the option to create. We're going to say local CA. And we need some label here, some common name, organization name, some kind of name here. What state you're in, state of confusion, and the country. Okay. However, this label really isn't always some. It's usually something like www ma nope, that's not what it is. This is some. I'm sorry. Common name is something like www.mydomain.com. So that is the actual domain subdomain that is going to be secured by this certificate. So this certificate, if generated just like this, wouldn't secure anything beyond www on mydomain.com. That wouldn't secure API. It wouldn't secure, demo or whatever else, what other subdomain. It's only going to be good for www. Now, I have discovered recently, because of some issues, that the smartest thing to do is just to go ahead, even when you've got a common name that's just a simple, simple domain subdomain, to also add that same common name or domain subdomain as a subject alternative name. The reason for that is that I read somewhere and experienced that it's actually no longer looking at the common name to validate the certificate against the domain. It's actually looking at subject alternative name. So in order to generate this cert, you add it here, and then you can generate this certificate, and it'll be valid only for www.mydomain.com. Now, key algorithm, I'd stick with RSA. And the only reason I'm going to suggest this is that I actually ran into a problem where I had both ECDSA and RSA certificates in my reverse proxy, which actually has multiple TLS secured websites referenced in it. And there was something that just didn't ever really work correctly when I had both RSA generated and or RSA key algorithms and ECDSA key algorithms in the same reverse proxy entry. So IBM just said, hey, just use the same key algorithm across all of the secured sites if you're referencing them in a reverse proxy like I was. And that's because I only have one external address. So all of the traffic comes to that reverse proxy instance, and the reverse proxy figures out what website is actually being referenced and then sends the traffic to another server, actually HTTP server instance. Okay, one other point beyond that. You may want to have a wildcard, okay? And I think that's a good idea. And you can generate one, self-signed, of course, through the DCM. I would remove this and I would add mydomain.com. It's always a good idea, even with a wildcard, to make sure that you've got both a naked domain and the wildcard domain listed. It just seems to work better. I've run into some issues where I couldn't secure the naked domain with a wildcard unless the naked domain was listed. So just leave it at that. And then for this, every subdomain on mydomain.com could be secured with the same certificate. Go ahead and generate that. It generates, and let's just go back and look at a few. This is the one I generated for PowerUp, this PowerUp demo. And you can see this is a wildcard. He's going to secure any subdomain and standard entries here. And then also, and notice also I've got both this and the subject alternative name of the naked domain. And then I've got another one that's self-signed. And how do I know it's self-signed? Well, I can do it two ways. I can see how it's listed, but I can also look at the hierarchy. And so this self-signed certificate is actually secured by my local CA, which is the domain or the certificate authority, the DCM. Okay, and then we have this little this application definition. We'll get into that in a second. But basically, that's what you're looking at. You generate a certificate, and most important thing is choosing the key algorithm, identifying the common name, and if you're going, and also the subject alternative name, which should be the same if it's just one subdomain, and it should be the naked domain if you're using a wildcard. Okay. So that's the basics of generating a self-signed certificate. Now, you've got to be able to use it. And so the way that you can use it, and let me just go back to my slide deck really quick. Is that you can identify which applications are actually going to be using this particular certificate. So let's take a look at that as well. Just want to make sure I'm not missing anything here. Jump back to our DCM. Okay, so If I was to look at, let's go back to this guy, this wild card. You can see that I can assign this to a whole host of defined IBMI applications. And where do these come from? Well, the out of the box, the services that can be secured already will be listed here as applications. You can see in my case, most of my applications, and I would call them IBMI native applications, are secured by the same certificate. I also, in addition to all of these IBMI applications that are, you know, uh, basically native IBMI services, let's find one here. We also have this, which is not a native or I would say out of the box service. It is just, it actually turns out to be an HTTP instance, as you can see, HTTP server. And so where does that come from would be your question. And assigning certs to this is as easy as, okay, we're in we're already in our wild card, which has already been assigned, but you could do it like choosing this. I could assign this wildcard certificate to this particular service, and it'd be good to go with that. So like I could do add. We go back and look at this. And you can see that you can have multiple certificates assigned to this to a single instance, which is A-OK. So like here, we have both PowerUp and ValAdd, which we really don't want to have. So go ahead and we're going to go ahead and remove it. Okay. But it's that easy. Select the certificate, select assign the certificate. Okay. All right. So the next step would be, and we're going to take a brief aside here, is if you happen to have an HTTP instance that you want to secure with either a third party or an IBM self-signed certificate, the way that happens, and let me just do a quick refresh. So you can see I got a boatload of different HTTP instances configured. Yeah, each one of them, was built either as a demo or for real world. And I do have this website called PowerUp 26. Take a look at the configuration. And you can see that this one's secured. I can tell for a couple of reasons or a couple of ways. I've got the SSL modules installed. I'm listening on port 443. I've set the environment for port 443. And here's the kicker. This is the application definition in DCM that you can assign certificates to. Now, when you actually, it's a two-stepper. When you create an HTTP instance, by default, it's just going to be on port 80. But then you can go back and you can configure TLS on that particular instance. And when you do that, you have the option as you go through. We don't want to disable the non-TLS port. It's giving me all these warnings because it's already in use. Um, in order to get to the certificates that are in the certificate store, we can either create, I recommend you don't create a new certificate from the local CA as a self-signed, that you go ahead and create a certificate first through DCM, and then you choose that certificate here. And so we would create this PowerUp website demo, or we could use the wildcard as well. Either one would work. And then we can assign it. And usually trusting all the CAs, we know that it's only the DCM, so we could have chosen that CA to trust. Okay, and then it's a restart option at the end, and I haven't. I typically don't restart it, or well, I restart it. Yeah, I restart it later by myself, just so I can see what's going on. But I'm going to cancel out of this because I already have a definition taken care of. And again, in that process, it's going to take the port 80 uh, kind of default setting, and then it's going to add really this section in here, the turning the SSL engine on, pointing to the app name that you've assigned the certificate to, and then it disables all of the unused or insecure protocols. And that's basically it. And then you have to start that, which is running right now. And we could then test it just to do www PowerUp. And here's the default sample, basic homepage. Okay. So that's how you go about using, and this one's a self-signed certificate. How do I know that? Well, let's take a look at a couple of things. If we go to the certificate manager in Chrome, you can see that the Valad PowerUp 2026 CA certificate, which is from here, has been imported. So it's going to go ahead and it will recognize any certificate generated by that CA. That's exactly what you want. Again, the kicker is you got to distribute that CA certificate to every browser if it's a web application that needs to be accessed, to every browser that every person in your domain would be using. And that's why self-signed certificates are not that handy. Okay. All right, what's next? Let's take a look at the slide deck here. Okay, we've assigned. We've taken a look at how to get these certificates that we've created assigned to an HTTP instance. And then again, if you need another application, if you're going to secure, for example, the database server or whatever, you can assign that certificate to that. I use a wildcard on valad.com as the certificate for just about all of the services on IBMI. Okay, quick review. Create that local CA certificate, export the certificate so it can be used by browsers and other applications. Then open the system certificate store, create a new certificate using the local CA, that's CA that you used. And then if it is an HTTP server instance, then configure TLS. Real straightforward. I've done it so many times, I could probably do it in my sleep now. Now, okay, so that's self-signed. Not as common as you'd think. Really, I would say that in most cases, it's a case where you're importing third-party certificates into DCM. Oh, and as an aside, again, another aside, you can also use a self-signed certificate um, from DCM, and you can package it up as a PKCS 12 and then export it as that and import it into another server. Like, let's say that you're also using the same self-signed certificate on a Windows server somewhere or a Linux server that's got Apache on it. You don't have to generate a new certificate. You can just export the certificate that is in DCM and use, well, you got one of two options. Well, I would say that the easiest option is just the PKCS 12, export that and then import it on the Linux server, the Windows server, or whatever, and use the same certificate that you've got in DCM on a different server than IBMI. Completely possible, very easy. In fact, you would do that here. Let me just jump back real quick to the DCM. So if we had, let's go back to System Store, and here it is. We've got this guy. We want to export this dude. We want to include the private key because it's going to be going to an external server that's going to need that private key since it didn't generate the CSR. And you can just go ahead and export it to downloads. And again, it ends up in a place in the IFS, which is, I think, QIBM, user data, ICSS, cert downloads. If you put it here, you can actually export it to the certificate store, or you can just create a file and export it there. And the reason that this password and confirm password is there is that in a PKCS 12 file, usually it has a password that is needed in order to import the both the private key and the certificate. I've just found it easier just to send it out to downloads. But it's up to you. You can export it though. That's the most important thing. You can have the exact same certificate in DCM and validated, and then also in another external server as long as you export it correctly. Okay. All right. Where were we going? Oh, we were going to go to creating a CSR. And the certificate signing request is a way to tell a third party, hey, give me a certificate. Here is our private key. It's encrypted. And you can build a certificate around that. And then I can import it and use that certificate as though I generated it as a self-signed certificate, although it's not going to be self-signed. It's going to be signed by you, the third party that my browser probably already knows. So we create we create a certificate for an internet CA, which means that we're going to generate a CSR. So in this case, we're going to call this a demo label, and we're going to give this star.demo.com. We're going to do this val add. We're going to do this in Texas. We are going to 78258. Oops. And we're going to do it in the US. And because this is a wildcard, we're also going to add demo.com as the SAN. Okay, I'm going to create this guy. Do not forget to grab this, okay? This is the certificate signing request. What's in it? Well, let's take a look at it. I use tools from SSL Shopper. There is a CSR decoder. You can paste that in there, and he'll evaluate And you can see there's the details. That's the info that I keyed into that certificate request. I highly recommend that you save this in a text file for future use, because that third party, whether it be Sectigo or whatever, they're going to want the CSR in order to generate the certificate for you. Now, I don't really care because I'm going to go right back. I've got a couple of CSRs here that I've created. You'll notice that these are two bogus ones that I'm going to delete. But you'll notice that all of these others that these are external, used in external CA. Let's encrypt to be specific. There's no longer a CSR hanging around here. And that's because that CSR is critical. Having it in DCM, it's critical because the certificate generated by the third party is going to look for the attributes that are in that CSR when it imports it. That's what DCM does to match this thing back up and use the private key that was generated when the CSR was generated. So all of that needs to stay put. And then once you import the certificate, CSR goes away and you should be good to go. So when you get that CSR processed, you'll get one of two things. I mean, you either get a notification that you can go to the website and download that certificate, or it'll actually send you an email with the zip file attached. And so at that point in time, then you're going to want to do one of two things. And I recommend if it's manually updating, then sent to you, then I would first of all choose to upload the file. And you'd have to find a certificate, I think I've got some certs floating around here somewhere. You would grab this guy, you would find the PEM file. Let's encrypt certificates, DHM. Is there anything in there? No. There's the wildcard. So you'd open that up, you would upload this file. That ends up in an upload folder in the IFS. So then when you import from a certificate authority, you can browse your uploads, find that particular, select it, and then continue. Now this guy's already in there, so he would bark at me on the import, but that's one way to do it. And actually, it's not a certificate authority one. I did that completely wrong. This is actually a server or client certificate. Select that guy. Okay, so there's this little flag here. It says automatically renewed. Okay, so if you are like me and you reuse your CSRs for not only the first time you get the cert, but the second time, and the third time, and every time after that, you're just renewing an existing certificate. And it's identical. Use the same CSR every single time. When you do it the first time, you leave this unchecked. When you renew using the same CSR, then you check that box and it's going to go ahead and renew the certificate that's already there. I know that there's a lot of folks that generate a new CSR and then, they go through the whole thing to import it again, which is a-okay. I just find it easier just to check this box and import the certificate again. And it takes care of it, updates it. Okay. So that's import. You can import also if you've got a PKCS12, which would also have a password associated with it. You can also import that. Even if you didn't generate the CSR from DCM, you can import this PKCS12 file because it has the server key in it. And so when you import it into DCM, it'll be happy. It will know that it'll have validation that the certificate and the certificate and the server key is correct, and will validate that particular um, uh, certificate. So again, not a lot beyond that. You're going to either make sure I'm not missing anything on my presentation here. Fee-based, CSR, yep. And then when it comes time to import, and that's something I skipped over. When it comes time to import, just make sure that the third parties CA roots are available in DCM. Let me show you what that looks like. We didn't actually look at all the CA roots that were there. Let me jump back to DCM. Let's get rid of these. Let's go ahead and do the certificate authorities. Okay, so you can see I've got quite a few. But like, for example, I don't have Sectigo in here. So if there isn't a root certificate for the certificate you're trying to import, third-party certificate, then you need to make sure the certificate root is here. Now, Let's Encrypt has got multiple roots and intermediates. It just depends upon whether you're using RSA or ECDSA. Makes a difference in what root certificate or intermediate certificate is going to be used. So I just imported all of them for Let's Encrypt. But just make sure that you've done that you've actually got the root certificate for the third-party provider in your DCM CA store. And if you don't, not a big deal. Just go ahead and import it. And again, you're going to upload it first, then choose it from your uploads, and then continue, and it'll import that certificate. I did that for I thought Cloudflare, yeah, because I didn't have that root. I needed to import it. Okay, back to the presentation. They all have a chain of trust. Sometimes it'll be certificate directly to root. Usually it's a root that's issued an intermediate certificate, and that intermediate is what issued the final certificate. So again, you may have more than one certificate in the certificate chain. PEMs are the most common, but I did mention the PKS12. If you didn't generate a CSR, sometimes a PKS12 file can be just a PKCS12 file can be imported directly because it's got the server key. And then you can again export your CA certificates. Again, like I just showed you, we could put it on any server if we export it in PKS12, PKCS12 file. Here's where you can find the Acme DCM, which is something we didn't go into, but I wrote an application that would basically handle all of the certificate renewals through an Acme client. I use Let's Encrypt. That's my Acme client. It automatically, when the renewal period is about to expire, it goes ahead, renews the certificate, pulls it down, imports it into DCM, and takes care of everything, so I don't have to think about it. And so happy encrypting. I hope you have a great time. If you have any questions, you got my contact information there. You are more than welcome to contact me, and I'll try to answer every question you have. So thank you very much. Really appreciate your attention. And again, got any questions, just let me know.